Rajiv ji, you're there?
Good afternoon, Shrestha. I'm there.
Good afternoon. Good afternoon. Actually, I'm not actually very well today.
Oh, you're not well today.
Anyways, Rajiv Day. In the meantime, others are joining. Let me show you something. You must be knowing it, but there is this website called pbeducation.org. I think the other TAs have also told about it. On this website, you can get everything like how this sunlight, what are the properties of sunlight, and how these semiconductors form different type of junctions, and how we implement it for solar cells and designing and arrays and their other characterizations. So what sir is teaching nowadays, the semiconductors and junctions, everything is available here. And the best thing about this website is you can get everything in the form of short videos. For example, let me show you.
Okay.
Yeah, this
If you
is
can
it.
write down the link on the chat box.
Oh, I am not shared a screen. I'm so sorry. I'm so sorry. Oh, just a minute. Now you can see. I'll definitely do it. Are you able to see my screen, Rajiv ji?
Mm, yes.
Okay. Okay. So now you see. Are you able to see the screen?
Yes.
Yeah. So I'm talking about this website, pbeducation.org. On this website you have all the basics, like from the introduction to the properties, the semiconductor and junctions, how it implement to the solar cell operations, and how to be implemented for designing of solar cells and the different characterization, and even the batteries. So
Okay.
what sir is teaching nowadays, sir, is just a minute. Yeah. So sir nowadays is teaching about semiconductors and their junctions. So sir is teaching. Sir has already taught about this. So the best thing about this website is you get everything in the form of videos. Like you can get a short clip, so that you can clear out your concept. Sir has taught about this recombination generation and this carrier transport in the last class. So if you see, everything is explained very well here on this website.
Okay.
For example, you see this movement of carriers in the semiconductors. They are specifically telling that how does it move in absence of electric field, how does it move in presence of electric field. So in very concise form, they have given every basic thing. So I would suggest everybody to go onto this website to see the 3D view of all the concept that we are talking about.
Actually, the exact link is not visible. So, what is the PV?
I'm just typing in the chat box.
Ah, okay. pveducation.org. Okay. Thank you.
Good evening, sir.
Good evening, Tanvir. How are you?
Good.
Good.
Sir, at the beginning of the beginning of the course, Ashish sir told that there are some textbooks that you need to follow.
Hmm.
Out of them, I got one like from the I got from the internet,
Hmm.
and another book there is called, the book name was Physics of Solar Cells or something. I just found on Amazon, but not on the ebook.
Okay, so you want a PDF of that book?
Yes,
Okay, definitely. Tanvir, could you write me in the mail the same thing after the class?
at your email.
Yeah, I have written my email everywhere, like the assignment solution that I share, and this is my email ID. If you can see this st19ip011 @isaac.ac.in.
Okay, sir.
And did you get the PDF of this book also? Like there is another book, if you know what sir has asked in the last class to follow. Oh God. Yeah. So this book is there. If you see Advanced Semiconductor Fundamentals by Robert F. Pierrett. Have you got this book or you need this one also?
You can share this one also.
Okay, so what Sir has taught, Sir has actually taught from this book only, the chapter 3, 4, and 5. 5, 6, especially 4, 5, and 6. You can get everything whatever Sir has taught in this book. Okay, so I'll share both of them with you. You just write me an email afterward. Okay.
Okay, sir.
Okay. And in fact, in the assignment solution, I write everything: the drive backup link, the YouTube channel link, and the website of best use. Wherever
Sir,
I'm.
where you have shared the assignment in the announcement section or what?
No, I have shared these link with you people already. I'm again sharing. We shared a solution of the assignment in this Google Drive. A Google Drive is there. I'm again sharing the link with you. And whenever I share the PPT, I show it to everyone. This is the Google Drive. You can see.
Okay.
Okay. Did you are you able to see the drive link?
Yes, I have already clicked the
Yeah, if you will open it up, all the TAs that we are taking, all the classes, the
yes,
solutions, the YouTube
yes.
link, and all the PDFs or the presentations, everything is present here. Okay.
Okay, sir. Sir, along with you, there are other two people who are conducting, right?
Yeah, yeah. DS also is present here. If you look, okay, let me show it to you once more. If you'll open it up, it will open up like this. So this week one classes are there. They are the YouTube link of all the three week one classes: Ravi, mine, and Harishankar. YouTube link, the presentations, and the backup videos. So this presentation folder link, in this folder link, if you will click on mine, so you will see that this folder will open up where I have already uploaded TAship Class 1 and TAship Class 2 in PDF format. You can download it from here. You see,
Okay.
solutions are here. Everything in the PDF format has been already shared. Similarly, the PDF, the class 1 also is being shared. You can download it from here. The detailed solution is there, and along with it I also try to, yeah, I mean, if you have not downloaded it, let me remind it to you once more. Along with it, like in the first class, I have actually made a summary of all the formulas. If you can see at the last, after the assignment, I have made a summary of all the formulas: solar time, solar position angles, all this, for which was a summary of first class. And in the class second, I have actually along after the class second assignment, I have actually merged the chapter 14 of NCRT. They are the basics of semiconductor electronics. Actually, I like this chapter because in this book you can find everything in very easy language. So here everything is given in detail, so you can go through
Yes,
it.
sir.
Okay,
Yes, sir.
so you can download it, and if you have any confusion anytime, you email me. Okay, because
Okay.
see, I am also a PhD student, so I am also in a learning phase, but I won't tell you anything wrong, but yeah, I'll try to satisfy your query because I may have more people who can tell me, and I'm in touch with sir also. So please do ask, but today I'm not well. Don't ask much questions, but you can email me anytime. Okay, anytime, whatever confusion you have, and please download them, they will really help you.
Okay, sir.
Okay, we are waiting 2 more minutes, then we can start. Today I'll be having a shorter session because I'm not very well, but still I'll take the class.
Sir,
Yeah.
sir, at the beginning of the at the starting of the course,
Hmm.
I opt for the exam and uh, I registered for the exam.
Hmm.
But recently, I have lots of a week two and week three. I was lagging behind week two and week three.
Hmm.
So I thought that I will not give the exam and I opt for the refund.
Hmm.
So is it important to give the exam or is it important to just do the course only?
See, you will get the certificate only if you give the exam. If you are attending the sessions to learn, you can learn. You're free to learn, but you will get the certification only if you give the exam. You getting me?
Yes, yes.
Yeah, that is the whole point. Anybody can join, anybody can learn. It is free, but if you give the assignments and then you give the exam, then only you will be certified.
Okay.
But if we had missed the exam, then cannot
That
we cannot clear.
I think there will be more than one exam if I have to clarify it. Uh, but I think if you are not giving exam, then they may not provide you the certificate. That's what we are being told, because they keep on sending mail register for the certification of exam. But
Yes, yes.
there will be more than one exams, I guess.
No,
No,
there
I'm
is
talking about the
only
assignment.
one exam only, I think.
Okay.
There is
I'm
only
asking
one
about the
exam.
assignment.
So
Assignment I missed.
what did you say, Rajiv ji?
I missed the three assignment deadlines.
Okay, okay. Okay, fine. So this thing I'll clarify from the professor and then I'll come to you because I don't know the exact rules. But I need to ask to NPTL and sir that if somebody has missed it, can they retake it, or if whatever assignment they have missed and others they are giving, will they receive the certificate or not? I'll clarify it to you, Rajiv ji and Tanvir.
Yeah, yeah.
Okay?
Because it was not done intentionally. I was not aware about the deadlines, so I missed
Yeah,
it.
I
Now
understand.
onwards I will take care. But the 3 weeks I have missed it.
Hmm. Okay. Okay, so I just wanted to share one thing before starting it. I have actually made a presentation. Tanvi, if you can see, this presentation I made, I will share it along with the today's PDF solution. Not made, I've taken from various places. Here, actually, we have talked about its intrinsic, extrinsic semiconductors and what sir has told in the last to last class, and the dependence of Fermi level on carrier concentration and temperature, and carrier generation in recombinations, PN junctions, diffusion drift. Till here, sir has already taught. So you can get everything in a very summarized way. Like if you want to do revision, what is Fermi level, what is, how does it happen, what is the forbidden gap, how does at 0 Kelvin a potential is there or not, and how do we calculate the EG. All this thing is very well written in this. So I'll share this PPT with you and you can go with it. I think only if, the starting 40-50 slides will be enough, but I'll share the whole because from here after this PN junction, this Schottky junction and this biasing, and then this semiconductor, solar cell, LED, solid state lighting, diode and photodiodes, so we'll be teaching in the next classes. So this presentation will be really helpful for you if you want to give a quick revision for some exam or something. So I'll merge this this PDF along with today's solution. Okay, so without delaying further, let's go to today's class. So I don't need to introduce myself. So today we have around 11 questions on the basis of week 3 classes. So let's begin. Whatever sir has taught in the class, these questions have been made on the basis of that. So the first question is, as it is seeing, we are seeing the bending is observed in the semiconductor materials when there is dash inside the material, and the options are no electric field, no concentration gradient. And you have 1 to 2 minutes to tell me the answers. You can type in the chat box the answers if you know. Are you able to see the question?
Yes, yes.
Yeah, so okay, so when there's electric field, But isn't it, Rajiv ji, that electric field?
No,
Uh,
it is A.
okay. What about others? Who is there? What do you think, Tanveer?
Sir, I don't know.
Just give a guess.
Sir, bending means the what is bending?
Okay, so you have not attended the class. We have this conduction band and balance band, no, in a
Okay.
semiconductor, and these bends bend, like they do not stay at their own positions, and certain factors are responsible for it. Okay, so if I have to explain you, then I may have to go to this slide only. This, if I can show you, I have put it this here. See, you can see there is a conduction band, there is a balance band, and there is a Fermi level. Okay, now this band,
Okay.
this band bends due to certain conditions, which sir has already taught in the
Okay.
class. In the last assignment, I have shared a question also. What are the reasons for the bending of these bends? So you can go through the class, and if you're not able to understand, you can ask me later. Okay. So I'm talking about these bends, if you can get a general idea. So let's go to the answer without delaying further. So the answer is, we can see, uh, the answer is B, when there is electric field. Rajiv ji.
Yes. Got it.
Yeah.
Uh,
Okay, so let's move to the second question. The second question is saying that electron diffusion current in a semiconductor is due to. I'm talking about the diffusion current. Electric field carry a concentration gradient, both carry a concentration gradient and electric field, or defects. Okay, so let's see. Because Tanveer, I think you have not attended the classes, so a little bit balance we have to make, anyways. So let me show you this diffusion current. Okay, so if I can see it on the website, if I can find it, yeah, here it is. You can see what is diffusion. Are you able to see my screen?
yes.
Yeah. So what happens? In the overview, we can see when light is incident on a solar cell, the carriers get generated on the surface. I'm talking. This website talks in terms of solar cell, but you can take any device, okay? And if the absorption is strong, all of the light will be absorbed near the surface, and no carrier will be generated in bulk. So this creates a carrier concentration gradient within the semiconductor. But when a carrier concentration gradient exists in the semiconductor through random motion, carriers will have a net movement from areas of high carrier concentration to the areas of lower concentration by the process called diffusion. With time, these carriers will diffuse throughout the cell until the concentration is uniform. Okay, I'll explain it. Just let me show you this video also. So this diffusion is a random scattering of carriers to produce a uniform distribution. If you can see, there are carriers at different locations, and if I can see, they are moving from their higher concentration to the lower concentration. Okay, now let me explain this in a very layman language to you. What happens actually? What is diffusion? We have read diffusion and osmosis, the movement of particles from the region of their higher concentration to the lower concentration. But when we are talking about diffusion current, that means we are talking in terms of diffusion in terms of electrons. That's it, nothing else. This is how we can understand it. So this is the diffusion, and there are the equations which are associated with it. For one dimensional diffusion equation, Jn diffusion equal to q dn dn over dx, where J and Jp are the diffusion current densities, q is the electron charge, d and dp are the diffusion coefficients of electrons and holes, and n and p are the electron and hole concentrations. And this depend on a type of the semiconductor also, like we have n type or a p type, which are the majority carriers, which are the minority carriers. Accordingly the definition also changes, but the general overview is this. So the question is that electron diffusion current in a semiconductor is due to electric field, carrier concentration gradient. I have already told the answer, by the way. There was a definition: both carrier concentration gradient and electric field or defects. And Rajiv D has said, I guess, something C. Okay, Tanveer, if you can tell me after seeing the definition, what do you think the plausible answer is? Sorry. Yeah, Tanveer, like just give a guess. You know about N and P type, right? Like what are extrinsic semiconductors and what lead to the formation of N and P type of semiconductors? What are impurities? Why do we dope them? And what happens when we dope? Is there some change in the carrier concentration, and what will be the implication of it? Tanveer. Okay, fine. If you're not there, uh, Rajiv ji has said the answer is C, but I show you the answer. The answer is only the carrier concentration gradient. I'm only talking about the diffusion current, and electric field is a result that happens when we apply some external stimuli. But this diffusion current, which is like, it could be available already inside a semiconductor, is due to the carrier concentration gradient, as clear from the name diffusion. Diffusion means the concentration gradient of the majority or the minority carrier are different in different regions, and these are trying to equalize all of them, and they start doing random motion, and due to this random motion a current forms, which is called diffusion current. Okay, let's move to the next question. This is a easy question. The third question is saying the absorption of a photon of energy EPH in a semiconductor material with bandgap EG takes place only when. It's a very easy question. When E photon is lesser than bandgap, E photon is very very less than bandgap, E photon is greater than bandgap, E photon is EG by 3, or E photon is equal to EG raised to 0.5. Acha Rajiv ji, I sent you some papers, if you have received them in the Gmail.
No.
I have sent you. See, I can show you. Rajiv.gyani@gmail.com was your Gmail ID, right?
No. Not Rajiv.Gyani.
Oh, then what was it?
I have again mentioned in the chat box today.
Oh,
It is
okay.
IV.
Just a minute, let me see. Oh, sorry, I'm so sorry. I'm just forwarding it to you just now, so that I may not forget. This
Okay.
is the question that you asked last time.
Yeah.
Yeah. And then then we can have one-to-one discussion after the class, if you
Okay.
want. Yeah, but not today. I'm not well today, actually. So let's move to the next question. The next question, Rajiv ji is saying C, and it's a very easy question. The answer is C, absolutely right. So let's move to the next question. The next question is, following simplification is used under the steady state condition in an n-type semiconductor. Here N and P are carrier concentration under arbitrary condition. Delta NP and delta Pn are deviations in the carrier concentration from the equilibrium values. Which of the following simplification is used? for a steady state condition in an n-type semiconductor? Any idea? Acha, we know in an n-type what are the majority carriers and what are the minority carriers. And if it's a steady state, with respect to time, it must be zero. So, depending on that, we can tell the answer. Like, it's a very straightforward, easy question. Steady state is there, n-type semiconductor is there. We know which are the majority carriers in an n-type, and if it's a steady state, that means it will tend towards zero. So, what could be the answer? Yeah, absolutely right. Tanveer, are you listening it? Are you seeing it? I mean, just say me.
Yes, yes, sir.
Okay, but I will share all this presentation that I made is I made like I collected only because it's very in concise form in 40-50 slides. You will be able to see whatever is being taught till now. The presentation I'll share
Okay,
definitely. Okay.
okay.
Yeah. Let's move to the next question. The next question is the correct relationship in the minority carrier lifetime and diffusion length in a n-type semiconductor is. And the options are LP is equals to root of dp tau p, ln equal to root of dn tau n, LP is equals to dp over tau p, LP is equal to root of tau p dp, or LP is equals to root of tau p dp by dp. I think I've made some mistakes in writing some options. Yeah, Tanvi, you want to say something?
No, sir.
Okay, let me show you this book also. It's a very nice book. In the meantime, if you are taking some time, you see from chapter number 5, here it starts recombination generation processes, where how this recombination, how this photon and how this heat is changing and its momentum considerations. These all things are there in very detail. Okay, from here only sir has taught most of the portion, and then there is
Okay, sir.
there is this steady state relationship that I was talking about, and how the steady state for n type, what is the steady state relationship, for p type what is the steady state relationship, and then there are some special conditions, we don't need to go through it, but yeah, then this surface recombination generation, some introductory comments are there, some general rate relationships are there. I'm saying it for you, Tanveer, okay? This you don't need to go. I mean, it's a little bit higher book, but yeah, you can try to understand. And
Yes, sir.
then after this, you see this bending I was talking about. We can discuss in detail once you go through it. And then
Okay, sir.
after this is the most important chapter that you need to go. Here we have talked about drift. We have talked about drift current. I mean, they have talked about drift current, and then mobility, theoretical considerations of it, and this is a very, and this you will be able to understand how this velocity saturation happens, and this carrier transfer and all this stuff. Then this comes the topic of resistivity. Sir has already told the derivations of it, the Hall effect, and diffusion, that the thing that we are right now talking about, definition and visualization, how this diffusion happens, and what is the equation of diffusion currents and its difference assumptions, and the Einstein relationship, and much more. So you can go through this definitely along with the presentation that I have given, and if you if you even see this search slide on 2x speed, you will be able to understand. It's not a space business, trust me. I am also like have left it a much before, but you will be able to understand. Okay, Tanvi. So
Yes, sir. Yes,
uh,
sir.
The answer of this third question is, fourth question is when d delta Pn over dt corresponds to 0. Because we know what are the majority carriers in n type, and as it is a steady state, we know for a steady state condition for simplification in an n type semiconductor, with respect to the time, the majority carrier should tends towards 0. So it was a very straightforward and easy question. Okay, the fifth question was the correct relationship between minority carrier lifetime and diffusion length in an n type semiconductor, and this is a formula based question where lp is equal to under root of dp tau p. Sir has already taught it in the class, and still if you want me to derive it, I can derive it afterwards. Let's move to the next question. The next question is saying, question number 6, the electrical resistivity of a n type, this is a numerical by the way, and I'll give you time to solve it. The electrical resistivity of an n type semiconductor in is 10 raised to power minus 3. It is 10 raised to power minus 3. Okay, minus 3 ohm centimeter with electron and hole mobilities of 800 and 300 centimeter square per volt per second. The donor concentration in centimeter per cube, per centimeter cube in a semiconductor would be. I'm again repeating question. They have given electrical resistivity in an n-type semiconductor, and they have given the mobilities of electron and hole both. But trust me, it is n-type. They both will not be of our use. The donor concentration in the semiconductor would be a straightforward formula based question, and you have 3 minutes to give me the answer.
Sir,
Yeah.
sir, you are doing research on what kind of subjects?
Okay, Tanveer, okay, fine. So basically, Rajiv ji, you may also not know me very well. You also listen. I am a second year PhD student. Don't call me sir. Okay, I mean if you are my age group, I'm a second year PhD student in material chemistry in Isaac Kolkata under Professor Sain Bhattacharya. My lab is termed as Advanced Functional Material Lab, and I work on designing materials basically. I work on perovskites. There are this new type of material which are called perovskites, and this is the next generation of solar cells. And perovskites are so much into business because of their optoelectronic and photophysical properties. That means you can play with the band gap very easily. They are soft lattices. So I work on synthesis of new phases of perovskites. I make nano crystals, I mean nano also and bulk also, and then we try to find out the application of it in different domains. Different domains are like, we try to use it for solar cell, LEDs, photo detectors, and then other field emitting transistors, FETs are there. And except that, we have also try nowadays we are trying it for some hard radiation detection like X-rays and other things. And except that, in my lab there are other fields also, like we work on battery, we work on water splitting, photocatalysis, and yeah, all these fields. So basically my material is a my lab is a material lab.
Basically means it is related to material science.
Yeah, exactly. what
In
do you
mechanical,
what what
you
what do you do, Tanveer? What are you doing?
basic. I started my engineering by studying diploma,
Hmm.
and then I both diploma and BTech in mechanical engineering. After I graduated, and now I did work basically, but right now I'm not working anymore.
Okay, so what are you looking for? Like, what is your approach for attending this course? What do you want to learn from this? Like, you want to get a connection, you want to know what is going on in the world, or you're interested to go for PhD? What is your target of attending this
I
course?
was my target is to like to go go internship or getting a job in solar field, solar industry, or this kind of job I want to get.
Yeah, let me tell you, Tanvir. I'll not take much time because Rajiv ji is also there, because today I'll be taking a shorter class for a reason, because it's Mahashivratri also, so I need to go to temple also, and I'm not well. So yeah, so what I was saying, ki Tanvir, see, uh, if you talk about solar is a very vast field. It's a very vast domain. Okay, like I have told in the very first class, we work on photocatalysis also. Photocatalysis means we use a solar light, like UV light, if you can say simply, for doing the CO2 reduction, like CO2 to CO, ethanol, methanol, in presence of sunlight, right? We are also working on doing photocatalytic nitrogen reduction, and this water splitting also we do. We try to split water into hydrogen and oxygen under electrical wires, that is electrochemically, and also under sunlight. So, and then there is solar cells. So you need to fix, like, solar field is very big. In solar field, what you want to go for? But as you are very new, you can do some internships. Definitely, first of all, find your interest, and then find out you want to go for material design, you want to go for application, or you want to go for devices, what you want to go for, and then accordingly you plan your career. You getting me?
Yes, sir. Yes, sir.
Okay, so let's go to the solution of question number 6. The question number 6 solution is this, and I'll share all this thing. The answer is 7.81 into 10 raised to power 18. We know rho, that is resistivity, equal to 1 over NDE mu n. Somebody is trying to join or what? So the answer, we know the rho is equals to 1 over NDE mu n. Okay, we know that it is given, E is 1.6 into 10 to the power minus 19, and D is given as 10 raised to the power minus 3. We can see 10 raised to the power minus 3 is the resistivity, and the whole mobilities we have, the electron mobilities we have, we put the value from here. The ND that we have to calculate, we have to calculate the donor concentration, which is ND. So we take the ND here. ND is equals to 1 over rho E mu n. Rho is 10 raised to a minus 3 given in the question. E, we know the charge on electron, 1.6 into 10 to the minus 19 coulomb, and n is 800. So after calculation we get the answer, Nd is equals to 7.81 into 10 to the power 18 centimeter inverse cube. So the correct answer is A. Okay, I'll share this all. It's a formula based question for a calculation of donor concentration in a n type semiconductor, where we have taken use of electron mobility along with the resistivity and put the values in the formula. As simple as that. So the correct answer was A. Okay, let's move to the next question. The next question is saying, when an electric field of intensity 10 volt per centimeter is applied across a semiconductor at a certain temperature, the average drift velocity of free electron is 100 meter per second. The electron mobility in centimeter square per volt in semiconductor is, the options are 7.5 is to cross 10 is to 2, 10 is to 3, 6.25 into 10 is to 2, 7 into 10 is to 3, 5.65 into 10 is to 2. And you have 3 minutes if you can answer this question, else I'll tell the answer.
E by E.
Hmm? Who is this? Somebody said something, right?
Yes, sir. Velocity by field intensity.
Yeah, so what will be the answer?
is the answer.
D.
Yes.
Okay. Others? Your formula was right, but I guess either you have done some calculation mistake or I have done. Let me show you the answer. We know VD is equals to mu E. The answer is 10 is to 3. Okay. Uh, okay. We know that VD is equals to mu E. From here, mu is equals to VD over E. We know V is 10, D is given 100, E is given 10. So this is 100 cos 10 is to 2 over 10. That means 10 is to 3 is the answer. The correct answer is V. Are you able to understand?
Yes.
Okay. Now let's move to the next question. The next question is saying a simple PN junction diode is fabricated using dash semiconductor and can be used as a dash. And the options are intrinsic unidirectional switch, extrinsic unidirectional switch, intrinsic bidirectional switch. And I'm giving you 5 minutes to think of the answer. This is a conceptual based question. It's a very easy question. And I just want to see who can answer this. So I'm giving you 5 minutes to answer this question. Yeah. You able to see the question, the screen, right?
Sir, C.
Okay, and why do you think? Okay, and why do you think so?
Sir, C. 3, number 3.
Yeah, why do you think so? Like, could you explain?
Actually, sir, I think in extending semiconductor, we do. Okay, sir.
Hmm.
So, if you use bidirectional, some in depletion region, some problem is there. That's why I think intrinsic.
Okay, so but here we are talking
Current
about.
will current will flow one direction in intrinsic normal PN junction.
Okay, okay, your concept is right, but let's see.
Yes.
But here we are talking about diode. Just remember it. So Rajiv ji is saying one, and why is it so, Rajiv ji? You can type.
Actually, diode is only unidirectional. It's
Yeah,
not bidirectional.
exactly, exactly. But why do you think it's intrinsic?
I take support of Tanvir in that.
Tanveer? Okay. Okay, so let's go to the answer. The answer is second, unidirectional was right, but it is extrinsic. Okay, so let's go to the explanation first of all. I have tried to explain this question like this. So we know the answer is second, extrinsic and unidirectional approach. So the PN junction diode is fabricated using an extrinsic semiconductor, and it can be used as a unidirectional approach. If we see a general figure of a PN junction diode, so a diode is a two-terminal electronic, that is an anode and a cathode component that conduct current primarily in one direction, as Rajiv ji said, that is unidirection, and it has low resistance in one direction, high resistance in the other. Now, what happens, there are two types of biasing. One is a forward biasing, one is a reverse biasing. What happens in the forward biasing? When the diode is forward biased and the applied voltage is increased from 0 at the initial level, no current is flow. It is because the external voltage is being opposed by the internal barrier, whose value is 0.7 volt for silicon and 0.3 volt for germanium, which are majorly used. Now, due to the majority carriers in both the regions, anode and cathode, electrons in N region and holes in P region, as soon as BB is neutralized, the current through the diodes increases rapidly with increasing applied battery voltage. Now, what happens in the reverse biasing? Let's see. In reverse bias, the negative ions is connected to the positive terminal of the battery, and the positive region is connected to the negative terminal. The reverse potential increases the strength of the potential barrier. The 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 potential barrier resists the flow of the charge carrier across the junction. It creates the high resistive part in which no current flows through the circuit. So what happens? There is no current, and negative region is connected to the positive terminal, by which a reverse path is followed, which is known as reverse biasing. Okay, so this is all what I can explain for it. And as far as this is concerned, I would like to take suggestion, the answer from here. If you can see, there was concentration law in intrinsic and extrinsic semiconductors. Yeah, so we know the extrinsic semiconductors, the addition of doping elements significantly increases the conductivity. So the doping is only possible in extrinsic, right? So yeah, we need a unidirectional approach, that means option B. But due to this factor of doping, which is only possible in extrinsic, not intrinsic, because in applied field they can start to move in opposite directions in intrinsic, but in extrinsic, due to the doping, it can be a pentavalent or a trivalent anion. We can introduce impurity in the semiconductor, which makes it extrinsic, and then we use it for generation of current. And there are different laws which is follows, like when the band gap is greater than ionization or not, depending on the donor level and acceptor level. We classify it as N type and P type on the basis of the doping we are doing, whether a pentavalent or trivalent, whether we are giving it for giving out electron or accepting electron. So this is only possible in case of extrinsic semiconductor. That is why a PN junction diode is fabricated using an extrinsic semiconductor in a unidirectional switch. Okay, let's move to the next question. The question number 9 is saying which of the following formula represent the correct formula for width of depletion region. It's just a straightforward question.
In the last question, it is because of doping it becomes extensive.
Yeah,
Okay.
intrinsic we cannot dope, Rajiv. The extrinsic we can dope. That is why it can be N type and P type depending on the doping that we are doing. If we are doing a trivalent, that means we are creating an excess hole, and if we are using pentavalent, that means we are creating an excess electron. Okay, so this is how we play with depending on what we want. So we introduce the impurity in the lattice. Okay, Rajiv ji.
Fine. Thank you.
Yeah. Question number 9 is this, a simple straightforward question. Which of the following formula represent the correct formula for width of the depletion region? If you know it, then tell. If not, then I'll tell the answer definitely.
please zoom a bit.
Okay.
Sir, B.
Okay. You sir has done the derivation of this equation in the class till now or not?
Yes, sir. Yes, sir. Yes, sir.
Okay, great.
Yesterday I just see sir's class.
Okay. Let's see the answer now. The answer is actually not B but C. You made a mistake. You made a plus into minus and minus into plus. The differential.
Sir, why the plus sign? Because in lecture only said to epsilon VBI by Q by uh,
Huh.
1 by Na plus 1 by Nd.
Huh. 1 by Na plus 1 by Nd.
And, same is Na plus Nd by Nd. This is okay. But only VBI by minus sign. Only
Uh,
VBI by is confusion.
okay, okay.
Okay,
So,
okay. Sir, yes, sir, yes, sir. Yes, sir. Okay, sir. Okay, sir. Okay, sir. I made mistake. Okay,
yeah,
sir.
yeah.
Minus. Yes, sir. Yes.
This is
Okay.
only the reason I put it because I myself get
Yes,
confused
sir.
in the equation.
No, no, sir. Okay, sir. Okay. I was wrong.
Okay. Okay, the 10th question is very like it's a theoretical question. It's not a optional question. I'm just talking if sir has done it. Derive the equation of resistivity for n-type and p-type semiconductors. Has it been done in the class? Or just for the sake of understanding, you join later. So yeah, who is this? No, Tanvir is Mele. Mele, I'm pronunciating your name right. Hello.
Yes, sir.
Yeah. So what I was saying that I have made a presentation, okay, and this presentation is this which I will be sharing. In this presentation,
Okay,
I
sir.
in this presentation I have made this a summary of all the classes. Like if you have want to have a quick revision, then you can go through it. I've collected these slides from many places. Here I've talked about basic semiconductors, intrinsic, extrinsic. Their various equations are summarized. If whenever you want to have a quick revision, or if you're confused, you can go through it. Okay, n type, p type,
Sir, I want this PDF. Sir, can I have this
yeah,
presentation?
yeah, I share it all. No, you don't know that we have this drive where we share all the videos and all these presentations. See in the
Okay,
in
can
the
I share, sir?
okay, I'm sharing you. I think there is this lack of confusion because this Tanvir is also saying was saying this thing. See, assignment one, when I shared a detailed solution, and along with assignment one, I also shared at the last this formula. This formula was there, no? What I say, this solar formula I made, that so that you can go through the formula in one page. I summarize all the formula of solar time, the solar position angles, and the radiation on a fixed surface. And in the second class, Mele, I actually put along with the solution, I put it a drive link and also the YouTube channel link of me. And along with that, I also put it. You were not there in the second class, but second class discussion was very good. I also merged chapter 14 of the NCRT because this is a very basic
Okay,
chapter from where you can learn all the things. So I merge it.
okay, sir.
So
Okay,
I am just giving you a link of drive once again. I'm just sharing. It is already in the chats, but I'm again sharing, and you can find of everybody. Like it's not like only mine is present. You're getting me? Our video recording, our PDF, everything is like we all three TAs are there. No, our video recordings,
okay, sir. Okay, sir.
everything is
Just
there.
okay, sir. Okay. I open that.
Okay.
Okay, sir. I just open. Sir, one thing, sir, I want to tell you, sir.
Hmm.
Sir, the incident angle, sir, cos theta.
Hmm.
Hello,
Yeah, yeah,
sir.
yeah.
Incident angle formula cos theta is very difficult to remember, sir. A huge one, sir. Is there any shortcut method to remember incident angle cos theta? It is a huge equation.
Okay. I
Huge.
don't know what to say in this regard, but if you
Yes,
see if you see this
because
if you see
I am not able to remember it.
if you see this formula sheet, no, you can stick it into your room and then you can try to
Phi
learn.
I can omega I can make by cos phi equals to tan inverse. Can do.
Yeah, that also you can do, but yeah, this is the formula. How is it made? If you learn the concept that how this has been derived, probably you may not have to remember it. Then you can actually, if you try to do the derivation once or twice by your hand, then you may be easily learning it. But yeah, don't worry, I'll find out a trick. I'm from North India. I'll try to correlate it with some short trick and I'll tell you. Okay. I'll try to correlate it with some short trick. I
Okay, thank you,
right
sir.
now don't know any short trick, but yeah, I'll tell you. Don't worry about it. Like we learned a
Okay,
period,
sir. Okay, sir. Thank you, sir. Thank you.
like we learned a periodic table and all. Definitely, I'll make a short trick for it. Okay. So without delaying any further, let's move to the next question. I was talking about equation resistivity for N and P types separately. So what is resistivity first of all? It is an important material parameter that is closely related to the carrier drift. Qualitatively, resistivity is a measure of material's inherent resistance to current flow, a normalized resistance that does not depend on the physical dimension of the material. Okay, quantitatively, resistivity is defined as the proportionality constant between an electric field impressed across a homogeneous material and the total particle current per unit area flowing in the material. That is, Epsilon is equals to Pj. So from here, J is equals to sigma epsilon is equals to 1 over rho E, where sigma is equals to Ip is the material conductivity. In a homogeneous material, we know J is equals to J drift, and as established with other equations like this, where sigma is equal to Ip is the material conductivity. In a homogeneous material, J equal to J drift. We know J drift is equal to J n drift plus Jp drift, that is majority carrier and minority carrier. If we replace this, we get mu dn plus mu pp epsilon. Therefore, it follows P is equals to rho is equals to 1 over Q mu naught n plus mu pp. This is the equation. Now, for the n type semiconductors, what will happen? This will be Q U N D. Okay, and for a p type semiconductor, it will be Q mu p and A, where whatever is like the majority carriers, according to that the donor and the acceptor. NDP type or a NA type, the equation changes, but the nature remains the same. So what we see in a non-degenerate donor doped semiconductor maintains in the extrinsic temperature, Nd is very greater than Ni, and P is nearly equal to Ni square over Nd, which is very much lesser than N. This result was established in subsection. It is, I have taken this from the book I will be sharing. Melee, this is a book, I forgot to tell you about this. This is a book, Advanced Semiconductor Fundamentals. And what sir has taught in
Okay,
the
sir. Okay.
what sir has taught in the last 2-3 classes,
Yes, sir.
sir has talked about these 4, 5 and 6 chapter. And this question is straightforwardly I have
Okay.
taken it from there, and this solution is also from there. I put in this
Okay,
question
sir.
in order to tell you that the equation of resistivity for the N and P type is same, just the nature is different because one has a donor, one has acceptor, one is having a majority carrier as access, one is having minority carrier as access, one is having electron, one is having protons. So for the N type, rho is equals to 1 over Q mu 1 Nd, and for a P type, rho is equals to 1 over Q mu P Na. That's all. Okay. If you still don't get it, I try to introduce with you with the
Okay, sir.
definition of resistivity. It's independent of the material
Okay, sir.
shape, size. What is the mathematical definition, and what is its formula for a N type and P type semiconductor? Like we know the general, like the resistivity is this, but the nature remains the same. So resistivity is there in N type also, in P type also, just there which are the majority carrier where accordingly the formula changes. Okay, now the last question of today's class is a very easy question, and it's a formula based question. It's a very simple question. So which among the following is not rightly meshed? in the thermal EF equilibrium. This is taken from the class notes, okay? You have 2 to 3 minutes to tell me. Sorry for the inconveniences today. Actually, I'm not well. But if you have any confusion, feel free to email
Okay,
me anytime. So you tell me the answer of 11 questions, then we can wrap up the class.
sir. E equals to del V.
Yeah, exactly. And what is the right formula?
No, rho,
Hmm?
QV.
No, it's not QV. Actually, the potential is minus, if I
No, no.
remember.
V
It is negative,
is
right? E is equals to minus delta V. Yeah,
negative. Yes, minus del V.
rest other formulas are right. Kindly remember it. Direct question can come. For PE, EC minus E reference, V is equals to minus 1 over Q, EC minus E reference. E is negative of delta V and rho is uh, proportional to the derivative of dE over dx. Okay, these formulas you need to remember. There could be a questions
Yes,
related to
yes.
it if you are taking the exam in the
Okay.
certification courses. Okay, so today we wrap up the class here only. I'll share these
Sir,
slides.
already I come.
Hmm?
Okay, sir. Sir, already I am access your link, sir. Thank you, sir. Up to assignment 2, I have already accessed.
Okay, great, 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 great. So
From this link, sir,
yeah,
I am accessed.
what
Only week 3 is pending, na, sir?
yeah,
Week
week three is
3.
pending. Week three is today. I'm taking no.
Week 3 is on.
Week three Ravi. Week three, see, week three Ravi has taken. Let me show you this. I am opening it on the screen. Week 2 till week 2
Okay,
we
sir.
all three have uploaded. Week 3 Ravi has taken. Today I will upload my classes and then Harishankar will upload. Then next week 4 will be there. So week 3 is pending. Ravi has already
Okay, okay.
uploaded. I will upload.
So sir, please upload week 3 because some assignment 4 is the pending date 22. I will learn the assignments.
Okay, okay, okay then.
Week 4 assignment due date is 22.
Yeah, okay, okay, okay,
I
fine.
think 21 or 22 to
Okay,
submit. Okay, sir.
okay then. Okay, Tanveer, okay, Mele. Then thank you for
Okay, sir.
joining. If
Okay,
you
sir.
have any
Thank you, sir. Today you are
if
not feeling well. Okay, sir. No problem. Yes,
have any
yes,
confusion, you
sir.
feel free to email me and I'll give both of
Yes,
them
sir.
the book PDF along with these slides and my assignment solution. All of them merged. I will
Okay, sir.
upload it and also I'll upload my video recording. Now somebody is joining. What should I do?
Okay, sir.
uh,
Yes, sir.
Kumar, hello.
Knowledge it.
Okay. So anyways, so I am finishing up the class. Then see ya. Bye.